everyone. This is Scott Schmidt of the Operator Training and Certification Unit. The limited treatment exams are the exams that I handle, and I'm going to be going through a walkthrough on how to do the math problems on here. Yes, we gave you math keys, but exactly knowing how to do the math has been and demonstrated something we've been requested. So I'm going to be using a Texas Instruments TI-30X2S calculator. This is the calculator that we recommend for all examinees, and the reason it is a two-line calculator, meaning you can see what you typed in here and then you can see your answer over there. Without further ado, let's go ahead and get to the practice exam. The practice exam can be found on the exam applications page on our website, which is michigan.gov/ which is a / EGLE operator training, all one word. Hit enter and scroll down. You'll find a button near the top of the page. It says exam applications, and there you will find all three of these along with the keys that go with them. So without further ado, let's go ahead and get this out of the way just so we can get this done with. All right, because I don't want to make this video super long. So on the second page here, you're going to see the very first one we come to. The water treatment system treats 4.1 MGD. MGD stands for million gallons per day. Wishes to maintain a chlorine residual 0.7 parts per million. How many gallons of 11.5% available chlorine will be needed? They need to feed per day to assuming it weighs 10.2 pounds per gallon. So the biggest thing that we need to do here first is what everyone struggles with math questions is seeing what it is asking for. And as you can see here, what it's asking for is how many gallons of bleach, right? So one thing I like to do when you first see a parts per million equation is go ahead and write the parts per million equation first, okay? And then this is going to be pounds of Cl2, which is pure, over million pounds of H2O, right? So I have my parts per million. I put it into my equation. Now I need to find my million pounds of water. Well, I have 4.1 million gallons per day. This looks like this, 4.1 million gallons for one day. Well, I need to get this to million pounds per day. And so the million is going to stay. We want that unit for, as you can see, pounds and gallons here. But I need to get my gallons to pounds, and there's 8.34 pounds per gallon. So that's going to cancel out, and this is going to just multiply through here. So I'm going to get 4.1 times by 8.34. You can see here my calculator, just like that. And that's going to give me 34.194 million pounds of H2O, okay, per day. So I like to keep it at 3 decimal places when rounding this. There will be a couple where we have to round and stuff. So, and then I take my million pounds, so 34.194, and put it there. And what I'm going to do is I'm going to do a cross multiply because this is assumed to be over 1. So just cross multiply this, and this will give you your answer here. Okay. So with the 0.7 times 34.194, I'm going to get 23.94 pounds of pure chlorine. Okay. So I have 24.94 pounds of Cl2. Now I need to get that to bleach. Well, if you've taken our math classes, one of the things that we've learned is to convert percents to decimals. And how we do that is go 1, 2 places to the left, like this, which gives me 0.115%. Now, in order to convert pounds of chlorine to pounds of bleach, all you simply do is divide by the percent, the decimal, like that. So I just realized I missed it. 23.94. So 23.94. Divide by 0.115. This gives us 208.17 pounds of bleach. Or, I guess it doesn't say it, but this is bleach. Gallons is bleach. Now we want to know how many gallons per day we're going to use. Well, it weighs 10.2 pounds per gallon. So if you think around that, if we just say it was 10, roughly, it's around 21 gallons, right? Because each gallon weighs 10 pounds. So now to get it accurate, all you do is you take the pounds per gallon and divide it. So 208.17 divided by 10.2 gives us 20.41 gallons. All right, so this is your answer, 8.41 P. All right, the next one, a water treatment plant produces 1,125 gallons per minute. The raw water has a demand of 0.45, and the system wishes to maintain a residual of 1.1 parts per million chlorine. How many gallons of 5.25% will be required to do this per day, assuming leaks? So the back half of this question, like right here where we did this, is going to be similar, right? The percent's different, but the front half is a little bit different too. First off, we need to know what our dose is going to be. Well, total dose equals demand plus residual. All right. Well, here we have a demand of 0.45 and a residual of 1.1. So this is going to be your total, what you have to use. So like right here, where we put 0.7, we need to know how much, which is going to be 1.55 ppm equals, and then it's going to be pounds of pure up top over million pounds of H2O. Well, here we're given a flow rate, and we're going to assume that it's 24 hours. So 1,125 gallons per minute. I need to get this to pounds per day. So I'm going to first convert my minutes, which are on the bottom. So that means I need to be up top to cancel. There's 1,440 minutes to a day. And then I need to get my gallons to pounds. And I know that 1 gallon equals 8.34. So if gallons are on top here, they got to be on bottom there to cancel. And just like that. Okay. So you see there's ones across the bottom here. So this means I only need to multiply the top numbers here. So 11.25 times 1,440 times 8.34 is going to give me this number of 13,510,800 pounds. Well, the thing about that is you need to get that to million pounds. So how are you going to do that? Because if you look, this is million, that is not. To get this to million pounds, you simply divide it by 1 million. And I'm going to go to the third decimal place. So this is going to give me 13.511. As you can see there, million pounds. So I'm going to take that just like before, put it here, and then cross multiply. So what I mean by cross multiply is you're literally multiplying those two. So I can show you. 1.55 times 13.511. Just like that. Okay. So 20.94 right here. 20.94 pounds of CO2. Well, now I need to get this to each. So you divide by the percent. So don't forget to convert this here with an added 0 there. So this is going to be 0.0525, which equals 398.86. Well, now I need to divide that by the pounds per gallon, which is 8.8. And that converts it to gallons, which gives me the wrong number here, 45.338. The answer is A. All right, moving on from the chlorine, let's go ahead and get to the next one, which is a fluoride question. How many pounds of 0.225% hydrofluorosilicic acid, 19.8 available, will be required to apply 1 part per million in a million gallons of water of natural fluoride concentration of 0.3? So this is where fluoride and chlorine are differ, okay? We only want 1.0, right, to apply. And so what it is, we only want a residual of 0.1, but we have natural. So the water coming out of the ground already has a 0.3 to it, all right? So this one's a little bit different. How much are we actually going to dose? This one is different because you have to subtract the two. So you're going to take 1 as what you want your residual to be, and you already have 0.3 there, so you're going to add 0.7 ppm. So this one's 0.7 ppm, all right? Now I need to go ahead and do just like chlorine. The parts per million equation works because F2 is the purest fluoride, and then million pounds of water. Well, I only have 1 million gallons. How do I get this to pounds? Well, we're going to do the conversion here. Gallons are on top. They need to be on the bottom. So this is going to be 8.34 million pounds of water. So 8.34 was here. So yes, then we cross multiply the two just like before. 0.7 times 8.34. 5.84 pounds of fluoride. The 5.84, and then I need to get it to the acid, and we use the 19.8. Divide by 0.198 like this, because you go 2 places to the left, and then we will get our answer. 4 divided by, well, I got 29.49 pounds of, I'm going to just write acid. I'm not going to write that big number. So 29.49. Hey, here's the proof. Okay. So that gets us on to some more questions here on page 3. These are about solvents. So in this, The water plant produces 1.2 million gallons. The raw water has 11.2 grains per gallon of hardness. If all the hardness is removed, how many pounds will be removed in 7 days? So we're looking for 7 days total. So what we're going to do is we're going to do 1 day. Well, how do you solve for this? Okay. So you're going to use the parts per million equation. And the thing about the parts per million equation is you need parts per million. And this thing says grains, right? Well, on your math formula sheet, you're going to find that 1 grain per gallon equals 17.2 milligrams per liter. But look right here, 1 milligram per liter equals parts per million. They're the same thing, okay? So back to this. So first off, we need to figure out our parts per million. And grain, and we got 1 grain equals 17.12 ppm. So we need to multiply the two. Gives me 191.74 ppm. All right, well, that works for me. Now I'm going to just go ahead and go right to and this is pounds of hardness, which if you don't remember, hardness is mostly calcium and magnesium. Now the two causes of it primarily. And then we're going to put our million pounds of H2O here. Well, how many million pounds do I got? Well, I got 1.2 million gallons, kind of like this, right? Over 1 day. So gallons up top have to be on the bottom to cancel. This 1.2 times 8.34. And that's going to give me 10.008 million pounds H2O. So go ahead and put it there. So 191, because this is a cross multiply. And this will give us our pounds of hardness. 191.74 times by 10.008 gives me 1,918.93 pounds per day. Well, how many days am I doing this for, though? I'm doing it for 7. So I got to multiply that number by 7. Gives me 13,432.51, which is the answer B. Pounds hardness. Move. All right. How many gallons of water can be treated through a softener that is 275,000 gallon grain capacity before the regeneration if the raw water is 18.7 grains per gallon and the finished is this? So basically what it's saying is you have this big filter. It's full of stuff, kind of like an ion exchange softener at home. The water comes in here at 18.7 and it leaves out at 7.2. So the question is first off, how many grains are you totally removing per gallon going through that? So the easy way to do that would be 18.7 minus 7.2, correct? And I'm not going to butcher this, so I'm going to make sure I use my calculator. It's 11.5, but I'm going to double check. All right, I don't want to be that guy. So 11.5 grains per gallon are being removed, right? Well, this wants to know how many gallons total. Well, if it can handle 275,000 grains and you're removing 11.5 grains per gallon, grains up top, grains on bottom cancels out and leaves you with just gallons. So 275,000 divided by 11.5 gives me 23,913 gallons. So C is the answer. It's actually a lot easier than you were probably thinking it was going to be, right? All right. A high service pump from a plant is used to fill an elevated storage tank that is 145 feet tall. If the suction lift of the pump is 25 feet, what is the total head that is needed to fill the tank? So a suction lift refers to as how much the water has got to be risen first to the pump from the well casing itself, okay? Kind of down here. And we're saying that this is 25 feet, and then it's got to be lifted another 145 here. So what's the total suction head? Total head of the pump, 145 plus 25 gives you 170 feet, which is D. A water system has a concentration of 1.8 parts per million of iron and a finished water concentration of 0.3. Plant produces 3,300 gallons of water per minute. How many pounds of iron will be removed in 72 hours? Okay, well, so how many? This is kind of like that grains, the one we just did. You know, imagine your plant, right? It's 0.3 here and it's 1.8 there. So how many grains or how many parts per million of iron are we removing? Oh, 1.5, right? Because you're going to subtract 2 through the plant. 1.5 parts per million equals pounds of Fe and million pounds of H2O. So do you see how the parts per million equation actually works for everything? All right, so I have 3,300 gallons per minute. Well, I need to know how many per day. 3,300 gallons per minute. So I got to get this to pounds first off. So 1 gallon on the bottom, 8.34 up top, like this. And I need to get minutes to days. So I'm going to do the cheating way of 1440 minutes per 1 day. Okay, that cancels that, that cancels that. As you can see, you multiply everything across top and nothing on the bottom since it's just ones. 39. That's bigger than I thought. Don't check, make sure I typed everything right. Yeah, I did. Okay. So 39,631,680. And I get that to million pounds. Well, you divide by million. And I'm going to get 36.632 million pounds. So 36.632. Oh, 39. 39, my bad. So 39, and then I'm going to cross multiply these. So 39.632, because see if I'm typing in right, times by 1.5 gives me this answer, which is pounds of Fe removed or pounds of iron, at 59.45 pounds of Fe per day. So how many days is 72 hours? 24, 48, 72. So times this by 3, 178.35 pounds of Fe or iron. So answer is B. All right. Good thing we took our time on doing these to make sure that things come out exact, right? Okay. So we have 1, 2, 3. I think 3 more, maybe 4. I guess I don't know. We got 4. We're getting there. Next one, considered easy. All right. A well producing 925 gallons per minute has an iron concentration of 1.4 parts per million. If using phosphate to remove iron, 4 parts per million of phosphate must be used to remove 1 part per million of iron. How many pounds of phosphate will be needed daily to remove all the iron? Okay, so first off, we need to know how many parts per million of phosphate we're going to dose, okay? Well, if the concentration is 1.4 ppm Fe, so the conversion factor is 1 ppm Fe over 4 ppm of PO4. PO4 is the chemical formula for phosphate, okay? So essentially, we're just multiplying 1.4 times the full 1.4 times 4. So we need to find 5.6 ppm of phosphate, all right? So this is going to be pounds of PO4 here, my million pounds of H2O. So I need to find my million pounds of water. Well, we're given a flow rate, so I need to convert this 925 gallons a minute, and so there's 60 minutes, an hour, 24 hours to 1 day. And you see I got that to days. And I need to get gallons to pounds, 8.34 gallons up top. I wanted to write it out this time, all right? So you can see this is where the 1440 comes. It's 24 times 60 for the minutes per day, okay? So 925 times 60 times 24 times 8.34 gives me, as you can see here, 11,108,808. So 11,108,880 pounds. Well, that's not million pounds. I got to divide it by a million. So 11.109. 11.109. Cross multiply them here. This will give us our answer here. So 62.21. And we have an answer of 62.21 right there. All right, moving on to the next one. Convert 5,750 gallons per minute to million gallons per day. Okay, so you first write your unit out like this. You need to get to million gallons per day. So you can do it the hard way or the long way, whatever. Per hour times 24 hours. And the gallons doesn't need to change because it's going to state gallons. So 50 times 60 times what is me? 8,280,000 gallons per day. Well, how have we been getting things to million divided by million? So 8.28 million MDD, which is answer D. All right, well, the next one is going to require a little bit of, so if the brake horsepower, okay, so first off, you're going to have to use the math formula sheet. BHP stands for brake horsepower here, okay? So if the brake horsepower is 11.65 while producing 310 gallons per minute, has a total dynamic head of 105, what is the pump efficiency? So first off, you're going to have to know the formula. BHP equals TDH times GPM over 3960 times EP. This right here is what we're looking for, okay? So this is going to require some algebra first off, okay? So we know the answer. Trying to figure, I ain't got a lot of room here. So 11.65 equals 310 times 105 over the 3960, right? Times EP. This is what we're looking for right here. So the very first thing to do is to move the EP to the top, which is to say move it over here. How you do that is you times it by the reciprocal, which means EP over 1, which is essentially what happens in the top and bottom. Well, whatever you do to this side, you have to do to this side. So I times that by EP. So now we move to the next step, right? So I'm going to have 11. I'm going way over here. Just saying, all right, 11.65 EP over here. And then I had all these numbers over here. Well, I'm going to tell you to go ahead and do the math. So 310 times 105. 310 times 105 give you 32,550. Well, now you need to divide that by the bottom, which is 3960. And that's going to carry on to another number. So then I'm going to have 11.65 EP equals 8.22. Well, how do you get this by itself? Well, you just divide this side by 11.65 and divide the other side by 11.65. That cancels, and that will give you a decimal for the percent that we're looking for. So 8.22 divided by 11.65 gives me 0.705. Well, in order to get decimal to a percent, you go 1, 2 to the right. So this will round out to 71%, which is our answer. So you need to use your math formula sheet because not everyone's going to have this memorized. And then you need to times by the reciprocal here and get EP to the top. EP needs to be on the top of the formula. Okay? 2 more. Okay. And I think they're both on the last page. Double check them. I didn't miss the map. Okay. This is the last one. The pump in your main well house has been replaced. The well driller dumps 11 pounds of calcium hypochlorite down the well. What is the initial dose of chlorine? Assume that calcium hypochlorite is 65% available chlorine. The well diameter is 18 inches, the well depth is 975 feet, and the static water level is 150 feet below the top of the casing. So the first thing I want to do, so we have to figure out what the actual dosage is in here. So what that means is our parts per million equation, we're given the top and the bottom. So we're given this one and this one, we just have to solve for it. And I'll show you how. Okay, so 11 pounds of calcium hypochlorite is dumped down the well. So what's the initial dose of chlorine? Assume blah, 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 blah. So what it's saying is, let me draw a little thingy over here. So what we're saying is if we have a container that's, you agree that this is probably half, well, that means 65%. So that part is how much is chlorine, pure chlorine, the top. In order to solve for that, it's like, well, what do we do? Well, first off, always convert a percent to decimal. In this question, 65% of 11 is percent of. Percent of means multiply by. So 11 times 0.65 is going to give us, I think, 7.15. But let's double check with our calculator. 7.15. That's our pure amount of chlorine. Now we need to get our million pounds of water. So one thing I want to point out here is Read the question. Okay, so this is 18 inches. Well, first off, that's going to need to be in feet. So you should always divide your 18 inches by 12 to get it to feet. So 1.5 feet. Well, the well is 975 feet deep, but the water is right here, which is 150 feet below. So what's our true height of water? How much water is really in this? Well, you need to do the 975 minus 150, which comes out to 825 feet of water. Okay, so why am I all doing this? What shape is this first one? It's a cylinder, right? So the volume of a cylinder is 0.785 times diameter squared times height. Okay, so this one, you need to have volume is 0.785 times the diameter, 1.5 times 1.5 times the height of 825 feet. Well, since this is feet, this is feet, this is feet, that's going to give you cubic feet, correct? Volume gives you feet times feet times feet, which is cubic. If you go back here, 1 cubic foot equals 7.48 gallons. So all I'm going to do is add 7.48 because that converts this to gallons. Well, on the other questions, 1 gallon equal 8.34 pounds. So if I want to get gallons to pounds, just multiply by 8.34 because this is pounds. So I'm going to do that in one step. I'm going to get my pounds in one step. So 0.785 times 1.5 times 1.5 times 8 at the back, 825, and 7.48 times 8.34. So we got 90,902.06 pounds. Well, how do you get that to million pounds? You divide it by a million. Doesn't it give me 0.091 million pounds? So where does that go? 0.091. It was right there. So now 7.15 divided by 0.091 gives me 78.57 parts per million, which is the answer B. All right, well, everyone, thank you for joining me. I hope that you find this helpful and having written out, described what I'm doing, and all of the above. If you have any further questions, feel free to reach out to us by emailing us or giving us a call at any time. Thank you and have a great day.